Good afternoon, advanced algebra students. I hope you're doing fantastic. We are going to do the last section for chapter 4 for this quarter for us. So section 4.4, adding and subtracting rational expressions. We've already talked about how to multiply and divide rational expressions. Now we're going to talk about how to add or subtract them. The key thing for us to notice as we go through these problems is whether we have common denominators or not. So let's talk first of all about how you would add what we call two rational expressions if the denominators are the same. So for finding the sum or difference in this example here, I have x over x plus 4 plus 5 over x plus 4. Now notice that since the denominators are the same, I can keep the denominator and then I can go ahead and add the numerators. So the denominator would be x plus 4. The numerators added together would be x plus 5. So that would be the sum of those two rational expressions. Let's go ahead and look at example number 2. Again, a problem where we have common denominators. So we've got 2x plus 1 over x squared plus 3x, and then we have 3x minus 8 over x times x plus 3. Now notice in this case that the two denominators do not look like they're the same, but it's really important when we are adding fractions that we always factor to see what similarities and commonalities there are. On our first denominator, if we take out a GCF of x, we can see that actually these two denominators are the same. They both have a denominator of x times x plus 3. So then we just combine like terms. 2x plus 3x is 5x, and then 1 minus 8 is negative 7. Now, sometimes when you are adding rational expressions, you will end up needing to simplify after you add or subtract. Let me show you what that would look like. Let's say I have, for example, 2x over x squared minus 4 minus 4 over x plus 2 times x minus 2. Now, if we go ahead and factor this denominator here, we can see this is adopts, and it can be rewritten as x plus 2 times x minus 2. What I would strongly recommend you do, if you have a minus sign in front of a rational expression, is change it to a positive, and then change the sign of everything in the numerator. So we can see that our denominators are the same, so we're going to write this as x plus 2 times x minus 2. And for our numerator, I'm going to add both of those, so 2x minus 4. Now, the reason we have an extra step here is that when we factor the numerator, which again, we only need to factor if it turns out you're going to be able to cancel, but when we do factor that numerator, you can see that something cancels out here, these x minus 2's. So occasionally that will happen. It doesn't happen every time, but you do kind of need to check when you're working with rational expressions to see if it does. Now that was kind of like the good news. The bad news is if we have two expressions that don't have the same denominator, we need to make them have the same denominator. So we have to identify what we call the least common denominator. And to do that, we're needing to find the least common multiple to use for the least common denominator. So let me give you an example of what I mean by that. Let's say that we have two expressions, x plus 2 squared and x squared plus 5x plus 6. If we wanted to come up with the least common multiple of those two expressions, the first thing that we would need to do is factor each. Now obviously x plus 2 squared is already factored. That is obviously just x plus 2 times x plus 2. If we go ahead and factor this expression here, we would get x plus 2 times x plus 3. So we always need to, when we're finding the least common multiple, we always want to factor first. Then step 2 is going to be to include one of each factor to the highest power it appears. Notice for this least common multiple, because x plus 2 appears to the power of 2, when I include it in my least common multiple, I do need to include it to the power of 2. Now, I don't need to write x plus 2 down again because I already have it shown here, but I do need to include an x plus 3 so that I have one of everything to the highest power it appears. Okay, let's do another example. Again, we're trying to find what we call the least common multiple. So let's say I've got x cubed minus 9x on one of my denominators, and then x squared minus 2x minus 15 on another denominator, and then x squared minus 5x on a third denominator. And I want to find what is the least common multiple of all of these expressions so that I can add my fractions together. Now, we're not actually worrying about adding the fractions here. We're just learning to find the least common multiple. So again, step 1 is to factor, and it looks like this would be x times x squared minus 9, or x times x minus 3 times x plus 3. This would factor into x minus 5 times x plus 3, and this would factor into x times x minus 5. So if I want to find my least common multiple, again, I need one of everything to the highest power that it appears. So I've got an x, I need to include that. I have an x minus 3, I need to include that. I have an x plus 3, so I need to include that. I have an x minus 5, so I need to include that. Now notice I don't need to include this x plus 3 because it's already listed here. I don't need to include this x because it's already listed here. And I don't need to include that x minus 5 because it is also already accounted for. Okay, so I hope you're kind of seeing the pattern here, and that is to factor and then make sure that you include one of each factor to the highest power it appears. Let's do one more example of finding the least common multiple. Let's say we've got x cubed plus 9x squared plus 27x plus 27. And then I've also got x squared minus 4x minus 21. Now this one is a little bit tricky. When I first looked at this one here, I was thinking, oh, let's try factoring by grouping. But because there's 4 terms there, but notice if I took out an x squared here, I would have x plus 9, and here, if I took out a 27, I would have x plus 27. So the factoring by grouping is not going to work. What I did is I tried synthetic division with positive and negative 1, 2, and 3. And it turns out that negative 3 does work. So if I do synthetic division with negative 3, I can factor. What this tells me is that one of the factors for this polynomial expression is x plus 3, and another factor is x squared plus 6x plus 9. Notice that the second expression can also be factored as x plus 3 times x plus 3. Now, when I want to go ahead and factor this expression here, this is obviously much easier. This is x minus 7 times x plus 3. So in this particular case, can you think what the least common multiple would be? Take a moment and see if you can write that down. What would be the least common multiple for example number 6? Notice that I have 3 of these x plus 3's, so I would need to include x plus 3 cubed, so that I've got all of those. I also need an x minus 7, but I already have that x plus 3, so that would be my least common multiple. Now, let's talk about actually adding the fractions using the tool that we just talked about. So let's see, example 6. This will be example 7. In this particular case, I want to add x plus 3 over x squared minus 1 to 2 over x squared minus 3x plus 2. All right, so the first thing that we need to do is see if the denominators are the same or not. The first denominator is adopts. The second one we can also factor. But we can see that they are not the same. So we need to determine what the least common multiple is using the steps that we just talked about. So I'm going to include one of every factor. I need the x minus 1. I need the x plus 1. I need the x minus 2. And I don't need to write x minus 1 down again because I already got that. Then what we need to do is multiply the top and bottom of each fraction by whatever factors are missing from their denominator. So since we need the denominators to be the same, we need to see what's missing. Notice on this first denominator, I have the x minus 1 and the x plus 1, but I don't have an x minus 2. So I'm going to multiply the top and bottom of this first fraction or rational expression by x minus 2 so that it will have the appropriate denominator. The second denominator is missing an x plus 1. So I'm going to multiply top and bottom of this rational expression by x plus 1. Now that I've done that, I can now add or subtract the numerators and then keep the denominator. So this least common multiple will be my denominator. And then what I need to do now is combine like terms on my numerator. Let's simplify this. 2 times x plus 1 would end up being 2x plus 2. If I FOIL x minus 2 times x plus 3, I'm going to get x squared plus 3x minus 2x, so that's going to be plus x minus 6. So I've got x squared plus x minus 6, and I'm adding 2x plus 2. Now let's go ahead and see if there's any like terms here. We're going to leave the denominator in factored form. I have my x squared here, so that's good. I have an x and a 2x, so that's going to turn into 3x. And negative 6 plus 2 is going to become negative 4. Now, we do need to see if by some chance there is something that can cancel here. So if I factor my numerator, I can notice that I can write this as x plus 4 times x minus 1. And I have on my denominator, of course, x minus 1 times x plus 1 times x minus 2. What do you notice about the numerator and denominator? They both have an x minus 1, so these can be canceled. And my final answer then for this problem would be x plus 4 over x plus 1 times x minus 2. So again, we determine whether or not the denominators are the same. If they're not, we find the least common multiple and use that for our denominator. Then we check to see what's missing on each denominator and put back anything that we need to put back by multiplying the top and bottom by whatever is missing. After we've done that, we keep our denominator and then we add all of the terms in the numerator. And if necessary, we simplify at the end. Okay, I'm going to do one additional example with you guys, and then we will be done for the notes today. These notes apply to lesson 4.4a and lesson 4.4b. So you don't have to watch 2 videos. Let's go ahead and talk about something called a compound fraction. Now, a compound fraction is essentially a fraction inside a fraction. To simplify a compound fraction, we're going to simplify the numerator and denominator separately, and then we're going to multiply the numerator by the reciprocal of the denominator, and I will explain that to you. So this is going to be example, I believe, 8. so example 8, I've got 4 plus 4 over x divided by 4 minus 4 over x. Now, what we want to do is simplify the numerator and denominator separately. So let's look at the numerator. For the numerator, I've got 4 plus 4 over x. We can think of this as 4 over 1. In order for these to have the same denominator, I need to multiply the top and bottom of the first one by x. Now I can add these and have a denominator of x and then a numerator of 4x plus 4. I'm just thinking if I might want to factor that. I think I'm going to factor that now, just so that I have it as 4 times x plus 1 over x. Okay, let's go ahead and look at the denominator. With the denominator, I've got 4 minus 4 over x. Again, I'm going to put a 1 here. I need to add or subtract by making the denominators the same. I'm going to have x for my denominator and 4x minus 4 for my numerator. Notice that this is 4 times x minus 1. So when we're working with a compound fraction, in other words, a fraction with fractions inside it, we simplify the numerator and denominator separately. Now let's go ahead and rewrite, or I should say simplify separately. We're going to rewrite the numerator as 4 times x plus 1 over x. And then the denominator is going to be 4 times x minus 1 over x. All right, now you know what to do. When we take a fraction divided by a fraction, we multiply the first fraction by the reciprocal of the denominator. So we keep the numerator the same, just like when you're dividing any other fraction by a fraction. And instead of dividing by this now, we multiply by the reciprocal. Once we've done that, then what we want to do is simplify any way that we can. Notice in this particular case that the x's cancel out and the 4's cancel out. So my final answer is going to be x plus 1 over x minus 1. Alrighty, I hope that that was helpful for you. Students do typically consider this to be one of the harder lessons of the quarter. And so please give yourself a little bit of extra grace if you're feeling a little overwhelmed by this. Just want to let you know that we'll do a lot more problems together. Thanks, guys. Bye.